The current leave strategy regarding room specialists has determined that, even if all goes according to plan, it would take an incredibly long time before this attempt becomes a reality. Employing our most recent 11 billion venture, the Deep Space Telescope has been instrumental in examining whether we are genuinely alone in the universe. By continuously providing evidence through its discoveries, the James Webb Telescope has discovered some intriguing, human-like objects far beyond Earth, bringing us closer to answering this important question. The journey to Proxima B is anticipated to take around 20 years, so it will be a while before we can speculate about the existence of life on that planet. Our quest for extraterrestrial life has persisted across all human endeavors to the point that we have produced a plethora of hypotheses and media about it. Join us as we explore the slow and steady discoveries made in the realm of galaxies and planets on the journey to uncover something we might not be ready to witness. The distant lights of other world scientists may have our fascination with our role and significance in the cosmos remains constant and is deeply ingrained in our nature to continuously seek a companion. No matter how similar we might be, this drive propels us toward finding answers. But even if we get closer, can we be sure these answers are what we're truly looking for, or are they just distractions? The most significant discovery in history was made in 2021 during the design of the James Webb Space Telescope. A rather audacious and speculative question regarding the capabilities of our technology arose. Could our telescopes in the future detect artificial light on far-off planets like Proxima B, the closest exoplanet to Earth? Proxima B is thought to be tidally locked, with one side always facing its star and the other side remaining in perpetual darkness. Similar to our moon, a speculative technological advancement could potentially move energy from Proxima B's day side to its night side using solar panels that draw power from starlight. A research project involving scientist Manis Ving as one of the authors revealed that a unique arrangement of solar cells on the day side may be connected to telescopes in the future. This is especially pertinent now that the James Webb Space Telescope has been developed and will enable us to expand our search for artificial light on exoplanets like Proxima B. In fact, it is no noteworthy that the James Webb Space Telescope was able to accomplish this exact task in 2024 using its higher resolution and more sophisticated capabilities. The telescope may have already detected the lights we were looking for, potentially ushering in a new era of scientific exploration. We should learn more about the world of exoplanets and galaxies to comprehend how this amazing feat was made possible. Since the beginning of recorded history, people have wondered about the possibilities of our place in the cosmos, who we are, where we come from, and where we are going. This curiosity is the foundation of the James Webb Space Telescope's JWST mission to explore Proxima B. Human inquiry has been focused on timeless but deeply difficult problems for centuries. With the development of contemporary technology, one wonders whether we are any closer to finding answers to these urgent concerns. Astronomers would be happy to share the most recent findings about the UNIE using cutting-edge instruments, but if you were to ask a physicist, he might argue that we are only just beginning to fully comprehend our existence in the universe. The efforts of astronomers and space experts who have been instrumental in developing new technology for the discovery of what may very well be life on distant planets are one way to achieve this. These instruments, though frequently disregarded by the general public, are a direct reflection of human development. Now that the world has been laid out before us, it is time for us to expand our horizons and grasp the universe with the same confidence. A key component of this mission is the James Webb Space Telescope, an invention of human ingenuity. This infrared space telescope has started to answer these perennial questions, expanding the realm of what is feasible in space travel. You may be asking what precisely this Proxima B is, also known as Alpha Centauri. To be clear, Proxima B is a super-Earth exoplanet that circles an type star. Super, the distinctive feature of Earths, is that they can be made of gas, rock, or even a combination of the two. Their sizes can vary, with some being twice as large as Earth and others possibly being several times more massive. Earth are planets that are more massive than Earth, but less massive than ice giants like Neptune or Uranus. Proxima is an exoplanet, which means it orbits a star outside of our solar system and fulfills the description of a super-Earth. Though it didn't spark much curiosity, the first possible evidence of an exoplanet was found as early as 1917. However, it wasn't until 1992 that the first confirmed exoplanet finding surprised researchers. Another exoplanet, discovered in 1988, was verified in 2003. As of April 2024, 5,653 exoplanets have been confirmed in 4,161 planetary systems, including 896 systems with multiple planets. To comprehend the significance of the fact that many of these findings orbit N-type stars, understanding that an N-type star is the smallest star type in the main sequence, thus the term red dwarf is essential. The most prevalent stars in the Milky Way are red dwarfs, but because of their low luminosity, they are hard to find, which makes finding planets more challenging based on their size and temperature. These stars are categorized and given different designations, such as M dwarfs. It takes 11.2 days for Proxima B to complete one circuit around its star, while Earth takes 365.25 days. Proxima B's mass is almost 1.07 times that of Earth, and its orbits may be estimated by taking into account the whole electromagnetic spectrum. The star emits far less light energy than the Sun, with over 85% of its energy being infrared radiation, with a wavelength range of 0.045 to 0.056 microns. Its total luminosity is only 1.6% of the Sun's brightness, and it only shines at 5 to 6% of the Sun's intensity. In the visible light spectrum, the discovery of Proxima B was revealed in 2016, but what distinguishes it from the millions of other stars, planets, and worlds in our galaxy? Proxima B is the closest known exoplanet to our Sun, which is why astronomers are especially interested in it. Although 4.2 light years may seem far away to us in the vastness of the universe, it is actually quite close. Proxima B is a member of the Alpha Centauri star system, which is a triple star system. Despite its low brightness, it is still one of the brightest objects in the night sky, second only to Sirius and Koppus. What makes Prox even more intriguing is that it may be habitable because it is located within the star's habitable zone, which is the region where conditions may be favorable for liquid water to exist. This possibility has sparked intense interest among space scientists, leading to further investigation of the system's potential to support life. This is where the James Webb Space Telescope comes into play. The four main objectives of the JWST are to look for light from the first stars and galaxies that formed after the Big Bang, study the universe's evolution, look into the formation of stars and planets, examine planetary systems, and investigate the origins of life. As the JWST continues its investigation of exoplanets like Proxima B, we get closer to understanding these goals. The mission's current top priority is looking for extraterrestrial life, which is especially pertinent given that humanity's natural curiosity about the unknown is a natural extension of who we are as a species, always asking questions, researching, and exploring everything that moves or stays still. It makes perfect sense that a mission like this would be carried out on such a large scale with a vast universe full of limitless possibilities. Consider the monumental task that lies ahead of us. We are fortunate to be the ones looking for signals from far-off civilizations. According to the hunt for alien intelligence, he may be compared to a high-stakes cosmic hide-and-seek game in which the cosmos is the hiding place and humanity is the seeker. Researchers in this area are similar to skilled detectives who listen for any weak, though no extraterrestrial visitors have arrived. The search for extraterrestrial signals is still ongoing. It takes patience, often spanning decades or even centuries, to gather data from exoplanets like Proxima B. This expanding field of exploration could one day lead us to confirm the existence of extraterrestrial life, or perhaps we will only receive ambiguous signals that leave us with more questions than answers. Regardless, the detection of lights or signals from distant worlds like Proxima B could represent the next great leap in humanity's eternal curiosity, with a quest for knowledge and technological advancement intersect in an exciting cosmic adventure. The finding of artificial lights or other signals from distant exoplanets like Proxima B would be a monumental step toward answering one of humanity's most fundamental questions. Are we alone in the cosmos? As the James Webb Space Telescope continues its work, its findings will surely spark further discussions. Despite this, we remain hopeful that one day we will find conclusive evidence that we are not truly alone in the universe. Research and perhaps even challenges to our understanding of life, intelligence, and the very nature of the universe. The potential implications of these discoveries go far beyond curiosity alone. The possibility of confirming life on Proxima B or another exoplanet would force us to rethink our place in the universe. Could life on other worlds evolve in ways similar to our own, or would it represent something entirely different? Would these life forms follow familiar patterns of growth and development, or would they challenge everything we know about biology and consciousness on Earth? Even if we don't find direct proof of intelligent life, the mere detection of artificial lights or signals from distant planets would still carry profound implications. It would mean that intelligent civilizations exist elsewhere in the universe, potentially capable of altering their environments in ways that we can recognize. This would suggest that intelligent life is not a rare phenomenon, but rather an inevitable outcome of specific conditions in the cosmos. However, as exciting as this potential discovery is, we must approach it with caution. The confirmation of extraterrestrial life raises numerous questions, including how we should respond. How will humanity react to the discovery of intelligent life? Will we approach it with respect, curiosity, and scientific rigor, or will the revelations provoke fear, or even political strife? As we go further into space, it is crucial to think about the ethical and moral consequences of our quest, since history has shown that unexpected findings, particularly those that contradict long-held beliefs, may provoke surprising reactions. What obligations do we have as stewards of Earth if we do find life, especially intelligent life, on another planet? What moral principles ought to govern our interactions with other life forms, whether they be microbes or advanced species, as humanity continues its voyage into the stars? These questions, which may not have straightforward answers, will surely be at the center of the continuing conversation exploring the quest for extraterrestrial life with tools like the James Webb Space Telescope is an exciting junction of philosophy, science, and the future of humanity.